Hello, everybody. So today's lesson is a continuation of yesterday's lesson, identifying key features of functions from graphs, tables, or equations. So we're going to pick up where we left off yesterday, and we are going to start with example 2. If we completed example 2 together in class, you can fast forward the video at this time to example 3. So example 2, a pendulum swings to 90% of its height on each swing and starts at a height of 80 centimeters. The height of the pendulum is in centimeters, y, is recorded after x number of swings. Determine the key features of this function. So I've already created the equation for us. F of x equals 80 times 0.9 to the power of x. I made a table as well as created a graph. So at this point, please pause the video so you can copy down the equation, the table, and the graph. Pay attention to the scale of the graph. I'm going to resume with the example in 5, 4, 3, 2, 1. All right, our first key feature, type of function. So this is an exponential function. And we know it's an exponential function for a few reasons. One, if we're looking at the function, notice our variable is in the exponent, making it exponential. If you're looking at our y values, those are not going up or down, in this case down, by a common difference. 80 minus 8 is 72, but 72 minus 8 is not 64.8. So I don't have that common difference. So it's not linear. And looking at the graph, which is curvy, this is exponential. So from our equation, from our graph, from our table, we can see that this is an exponential function. Intercepts. So looking at both the table and the graph, we can see we have a y-intercept here at 0, 80, and we can see it there on the graph as well, our y-intercept of 0, 80. Remember, intercepts, x and y-intercepts, occur where our graph crosses the x and y axis. So as we see from our graph, we have our graph crossing the y-axis at 80, hence the y-intercept of 0, 80, but not crossing the x-axis, so we won't have any x-intercept. Intervals of decreasing and increasing. So for exponential and linear functions, it'll be either or. So looking at our y values, notice they're decreasing, which we can see in the table, going from 80 to 72 to 64.8 to 58.32, as well as in the graph, we can see that curve going down. We have a decreasing function. We also can see that it's only swinging to 90% of its height each swing, so it's decreasing by 10% each swing. Intervals of positive, negative. So since this graph represents the height of a pendulum swing, that's always going to be positive. So as long as x is greater than 0, we'll have a positive function. Maximums and minimums. So taking a look at our graph here, we can see that we have a maximum height of 80 centimeters. And since it's a decreasing function, 80 will be our maximum. We can also see in our table, 80 is the largest y value. The biggest swing will be 80, and then it decreases from there. And there's no minimum because, again, it's an exponential function. So exponential functions have those asymptotes, so it won't have a minimum. So that brings us to our last key feature, our asymptote. Since we have, it's kind of hard to see our asymptote here in this equation because the graph is just a tiny little snippet, but eventually, if you think about it in the context, if a pendulum is swinging, it'll eventually get closer and closer and closer to having no height at all and not barely be swinging. So y equals 0 is our asymptote. All right, let's take a look at example 3. If you fast forward, welcome. Example 3. A ringtone company charges $15 a month plus $2 for each ringtone downloaded. Determine the key features of this function. So I, again, came up with the equation for us. $2 a month plus 15 to start, so that's a linear equation. And from the table, we can kind of see starting at $15 and then getting $2 for each ringtone. So $17, $19, $21, $23, $25, $27 based on how many ringtones we end up downloading. So let's identify our key features. If you need to pause for a second to get all that information down before we start, please do so. So our first key feature, type of function. This is a linear function, which we can see from the table with a common difference. I'm adding 2, adding 2, adding 2, adding 2. So I have that common difference of plus 2. We could also see from our function that that's a linear equation. Y equals mx plus b. Looking at our intercepts, I have an x-intercept right here. So again, from a table, I think I said x-intercept. I have a y-intercept of 0, 15. Y-intercepts occur when x equals 0. X-intercepts occur when y equals 0. So y refers to our monthly bill, which will never be 0 because we will always at least have to pay $15 a month. So I will not have an x-intercept, I'll just have a y-intercept. So when x equals 0. Intervals of increasing and decreasing. Looking at our y values, they are going up. My bill will never decrease. My bill will only ever increase from $15. So this is an increasing function. Intervals of positive and negative, same thing. My bill will always be positive. I'll never have a negative bill. The phone company will never pay me money for their service. So as long as x is greater than 0, we'll always have an increasing function. And same thing for max and min. I will have a minimum bill of $15, but I'll never have a maximum. If I keep buying ringtones, I'll keep paying more. So no maximum, but I will have that minimum of 15. Looking at the y values, we can see that minimum value, but continuously increasing. And then finally, asymptote. There's no asymptote because this is a linear function and only exponential functions have asymptotes. All right. So with your remaining time, you should work on your homework. Your homework tonight is assignment number 6, which is key features of functions. In your homework packet, we are skipping assignment number 5. We will do that. That'll be Friday's homework. But because of the order in which the block day fell, we skipped lesson 3 and assignment 5, and our homework tonight is assignment number 6. So you have the remainder of the period to work on that, and I will see you all tomorrow.